Today our topic is dielectrics and polarization. Dielectrics are insulators which are able to transmit electrical effects. And we are familiar with the different types of insulators. And some of these dielectrics are polar and some others are non-polar. Polar means in the normal state they will have some dipole moment. Non-polar means in the normal state they do not have any dipole moment. Now we can take examples of polar and non-polar dielectrics. So I'll give examples. Polar dielectrics. For polar we can take example of HCl, H2O, etc. These are polar. Since they are polar, for example, we can consider a dielectric like this. We can draw the shape like this. One end will be positive, other end will be negative. And they will have a non-zero dipole moment if it is a polar dielectric. And what about non-polar? For non-polar dielectric, example we can take for non-polar H2, hydrogen molecule, nitrogen molecule, etc. Here what is the difference? The charge centers will be staying together. So they are not separated. So the net dipole moment is 0. The dipole moment vector will be 0 here and it is non-zero here. So dielectrics are insulators which are able to transmit electrical effects, and these two will come under dielectrics, polar and non-polar dielectrics, or polar and non-polar molecules. So for polar molecules already in the normal state they have some dipole moment. So dipole moment is non-zero. So they have some dipole moment. They behave as a dipole. Non-polar molecules in normal state they do not have a dipole moment. So dipole moment is 0. Now how can we polarize a non-polar molecule? That we are going to see now. Now I will draw a diagram here for a non-polar molecule. Let us take a non-polar molecule and we can draw a non-polar molecule like this. This is a non-polar molecule taken in a container and these are the molecules. I am drawing 6 molecules here, and for these molecules you can see that non-polar, the charge centers are staying together. There is no difference. Plus and minus will be centered at the same place. So I can say here what is the dipole moment? Dipole moment is equal to 0. Now what I am going to do is I am going to apply an electric field. So the same I will draw here. I have an electric field. This is positively charged plate and this is a negatively charged plate. So between these two plates I have an electric field. Here I have electric field and this is the direction of the electric field. And in this electric field I am going to place this dipole. So I have the dipole, same dipole I am placing here. Same dipole means the same dimension. Now what happens? So these are 6 molecules. Now for these 6 molecules there will be a slight change in the charges. So we can draw like this. These are the 6 molecules. But what happens is because of the positive charge, negative charge of this non-polar molecule will be attracted towards the positive charge. Plus comes here. Again this negative charge will attract the plus here and negative comes here. So this will be arranged like this. Charges will be redistributed like this. Okay. Now charges are slightly separated of each and every molecule of this dielectric. Now it possesses some dipole moment. We can say it is induced dipole moment. We are inducing dipole moment for this non-polar molecules. Now after polarizing, this is called polarization using external electric field. After polarization, let vector P is the dipole moment per unit volume. Per unit volume of the dielectric, let P be the dipole moment per unit volume. And it is seen that if we increase the electric field, the dipole moment also increases for the induced dipoles. So we can write the relation vector P is directly proportional to external applied electric field. This is applied electric field, P proportional to E. What is P? P is the dipole moment, induced dipole moment per unit volume, per unit volume of the dielectric. This is vector P. So vector P is dipole moment per volume. And E is the electric field. So vector P proportional to vector E means when we increase the electric field, more and more dipoles will be produced, dipole moment also increases. And if we decrease electric field, dipole moment will be reduced. So they are directly proportional. Now we can introduce a constant here. we can write a vector P is equal to, I need a constant here. That constant I substitute as chi. Chi or chi is a Greek alphabet. It indicates that electric susceptibility. Electric susceptibility. So this constant is called the electric susceptibility. Chi is a constant. This determines to what extent this particular dipole can be polarized. This is a constant value and it decides how much we can polarize that particular dielectric material. So vector P is equal to chi into E. Chi is a Greek alphabet and it indicates electric susceptibility. This is called the polarization. So we can polarize a dielectric. Some dielectrics are polar dielectrics. They already have some dipole moment, no need to polarize. But these dipoles, we need to polarize. If you want to transmit electrical effect, we need to polarize them. How can you polarize them? By applying an external electric field, we can polarize them. And it is aimed that if you apply more electric field, more dipole moment per volume will be produced. Okay, thank you.